conditional on income. Okay? So, what happens when we repeat our observations of income and consumption over 10 years, for example? So, in that case, we have created a panel data set. How to use this panel data set? What to do when you have a panel data set? The first possibility is to use a pooled sample. So if you have 10 cross-sections, you can mix these observations and obtain a pooled sample. You add time dummy variables because you want to control for potential effects due to time, okay? And then you use just OLS to get your estimators, okay? The thing is that if there are unobserved factors, okay, so especially those who are specific to individuals and that might be constant over time. In that case, of course, you will not be able to control in a pooled sample for these time constant unobserved effects, okay, in the same way as in cross-section. So if you have this kind of unobserved effects specific to individuals in the error term, then all your estimators will be biased in your false estimation, okay, pooled OLS estimation, okay. So this means that in that case, the pooled sample cannot do better than the single cross-section. The second possibility appears when the unobserved individual factors are not correlated with the explanatory variables. This means that the zero conditional mean assumption is verified. In that case, you can use pooled OLS estimation. This pooled OLS estimation provides unbiased estimators that are in fact more precise than with a single cross-section because the sample size is larger. However, there is a problem here because the pooled OLS estimation technique fails to use the time series dimension of the panel data. So remember that each individual is observed repeatedly over time, so there is a time series for each individual. And in fact, it's a problem. Why? Because each individual has time constant features that may not be observed. So, for instance, we could have gender, ethnicity, the educational degree when these individuals were young, so when they were studying at college. Okay, so there are a few things that are specific to individuals that are time constant. Okay, we know that these time constant unobserved individual factors are not correlated with the explanatory variables. So these time constant unobserved individual effects do not cause any concern about the zero conditional mean assumption. So we know that we won't have a problem of biasness of estimations. However, we may have a problem about the time dependence in the error terms, okay? Because this time constant unobserved individual factors will be there at each period of time. So in fact, the problem here is serial correlation, because we have the time dependence due to this time constant unobserved individual factors that are in the error terms. Okay, so in that case, the pooled OLS estimators are not that efficient. So there exists a better estimator, which is called the random effects estimator, which takes into account these random time constant individual unobserved factors across individuals. So in that case, and we will talk about this in much more details in question number 4. So the conclusion of this section, this small section B, is that when you have a panel data set and you have checked that your unobserved individual factors are random, then use a random effects estimator rather than a pooled OLS estimator.